So up to this point, we have faced our part, rough faced and finish faced our part, and rough profiled and finish profiled our part. The only operation we have left to perform on this op, on op 1, is to break the edge on the top of the part. And how we're going to do that is we're going to use a 1/4 inch chamfer mill that is designed for that. It's a 1/4 inch in diameter. It is 90 degrees at the tip. The 90 degrees is very nice because a right triangle, for every amount of travel in X, you get the same amount in Y. So it's very handy tool. This is a carbide tool. 2 flutes. Let me pull up my model here, and I'm going to go to the right-hand side. I'm going to pull up my edge brake, and I am going to simulate what this is going to look like. So here's our tool at our feed plane. Now, our feed plane is at 200 thou above the part. But this one here is from whatever, I didn't adjust it. So as we hit play, we're feeding down to our cut depth, and notice how we are offset from the stock. So I'm going to pause it right there. So that's where we need to land on the cutting edge to put a chamfer on the edge of this part. So if you can take a look at this, the diameter of the part, we're going to use frame to do this. We're going to have to use, we're going to have to address the radial offset and the axial offset from the tip. Because notice we are down below the top of the part. We just must have our cutting edge. Can I zoom in there anymore? We must have our cutting edge intersect this corner. So what I typically do, so our edge brake is 20 thou. We decided that from the print. Under all edges must be broken 15 to 30 or so. I forget what the heck it was. So I decided on 20. So I decided how far up the tool to go. And I believe I chose 70 thou. Okay, this side of the tool is only 1/8 of an inch tall. And we have the flat at the tip that happens when they grind that has to be taken into account too. So this is going to be a little difficult for us. So first we need to decide which tool our edge brake tool is going to be, our chamfer tool. And let's go ahead and number our tools sequentially, so we'll call it tool 4. So to insert a tool, I will get below where I want it to be inserted and then come down and F3, insert. Brings up my insert options. I'm going to select tool. Tool number is going to be tool 4. A description of the tool. 1/4 inch, 2 flute, chamfer mill. Okay. The position on the tool change is if I need to move the table to a position to get the tool change to happen. We are not going to do that, so we're always going to leave it empty. Tool height offset is going to remain the same as our tool number, as is the diameter offset. Okay, the diameter of our tool. This is one of the things we're going to mess with to get our tool to come into an edge brake. If I call this tool a 1/4 inch tool, cutter compensation is going to turn off and it's going to offset 1/8 of an inch. And that cutting edge is never going to come near our part. So I actually need to fiddle with this number a little bit. I'm going to call our chamfer tool 1/8 of an inch. I'm going to call our 1/4 inch tool an 1/8 of an inch, so it will cheat in to our part so we can get it cut. Spindle speed, okay. Calculator. 3.82 times 300 equals, divided by points, I'm just going to say 2.5. Okay, 4,500. The spindle on this machine maxes out at 4,500. So we're just going to go with 45. Spindle direction is going to be clockwise, so I don't need to hit the space bar. Coolant is going to be off, and yes, it's going to be an actual tool change, F10. Okay, tool change has happened. Now I need to call up my tool path. I'm still in the insert screen because we see the gap right here in the box. We are going to insert a cycle, a can cycle, and we're going to use the F7 frame can cycle. Now, notice what it did. It has pulled in some numbers from previous tool paths. It has guessed at what I'm going to do. So take that into consideration. The computer is not smarter than you. All right? This could be bad information. As a matter of fact, it is bad information. Because we decided to use center to define this rectangle that is our part. So where is the center of our rectangle in relationship to the work coordinate system? It's at 0. And the reason we know it's an absolute location they're asking for is it does not say incremental off to the right like it does down earlier. Okay? Probably would be more helpful if it said absolute out there, but if it doesn't say incremental, it is absolute. So the center of our box is at the 0, 0 where we put our WCS. Matter of fact, that's why we put our WCS there, is to make our life easier. Surface height. Where is the surface height of our stock right now in relationship to Z? It is not 30,000. It is at 0. It was at 30,000 until we did that last facing pass. So now it is at 0. And the whole purpose of the surface height question is because it's going to spit G code where it's going to wrap it in Z to 200 thou above our stock. So we have to define where the stock is. And that's what that's all about. Okay, length. Let's go ahead and leave our frame size the actual size of our part. We will offset radially by messing with our tool diameter. Okay? So 6 inches and 1 point, oh, let's see what that's all about. Do I even have my computer up? Yes, I do, right here. Let's see. 1.735, and that is correct, 1.735. Corner radius, so this is kind of nice. It has brought stuff forward that is good, so I'm glad to see that. Okay, depth. I do not want to go down to the bottom of my part. So how far below the top of the surface do I want to go on this 90-degree edge of the cutter? So I told it the diameter was 1/8 of an inch. So that means the cutter is going to cheat radially in towards my stock half of that, 0.0625. Okay, so let's try 0.0625. And I want to do all of that per pass. Plunge rate 25. We are going to be cutting here. So for my plunge rate, I need to do some quick feed rate calculations. Who remembers what the formula is to calculate feed rate? Feed per tooth times the number of teeth times RPM, times. Feed per tooth, number of tooths, and RPM. So, I already know the RPM is 4,500 times 2 teeth times, I'm going to do a 5 thou chip load. So 45 inches a minute is my feed rate. So cool. I am going to leave this plunge rate at 25 to help out my tool a little bit. Come on, we can do this. There we go. So 45 for my feed rate. And we are going to climb. We're going to do climb tool paths unless there's a reason not to. All right, and accept. So now what I want to do is I want to graph my edge break. I'm in the insert screen. I need to come out of it, so I'm going to hit escape once. I'm going to hit F8 to graph my tool path. Okay, this is from the top, and you can see the 3 rectangular rings. The farthest one out is my roughing profile. The next one in is my finish profile, and the closest one in is that edge break. So the intel I can glean from this top-down view is if everything is centered in the same place. That's about it. It looks like it should be right. So let's go ahead and change views to, I'm going to look at the front view. Okay, and I'm going to zoom on in because what I want to show you is these 3 right up here. Well, actually, yeah, so these 3. So I have my rough face, my finish face, and then this guy is how far down the tool is, the tip of the tool for my edge break. So that's about the best I can model so far. So I'm going to go ahead and I'm going to save this by hitting post.